All right. What do you guys think of automatically when I say the Pythagoras Theorem? Excellent. Emily won't think this because Emily has sat through this lecture before. You all immediately think a squared plus b squared equals c squared, yes? Automatically. And a and b are the legs, and c is the hypotenuse. And the problem with thinking of it that way is twofold. One, if the letters change or there are no letters written on the drawing, kids tell me they can't do it, which bothers me. Problem one. Problem two, if the letters are mixed up and I label the triangle with the letters in different places, kids tell me they can't do it. Those two things bother me. And thirdly, three things bother me. If you know the hypotenuse, then of course you are not doing a plus b equals c. You are doing c minus a equals b. And that's the other mistake kids make. They will do all the work and they will tell me that A or B is longer than C because they don't bother learning actual algebra and what the theorem is. Okay? Those three things bother me, which is why I don't like teaching it that way. All right? I do not say A squared, B squared, C squared. I say something else. We'll come back to that in a minute. All right? The first thing, before we get to that, though, I want to discuss if indeed you know stuff about the hypotenuse and the legs. What are some things you know about the hypotenuse? Emily. That is the most important one. It is opposite, and in geometry, opposite means across. Everybody highlight, underline, put a bunch of grade 5 teacher stars around it. Give it the blue cloud that your elementary school teacher drew around everything. Learn that. Opposite means across. Because in the 10th grade, we do not draw your triangles this pretty like to help you, like you are 5 when you learned this stuff. Sometimes the triangles look different. So we expect you to be able to work with it. Opposite means across. The hypotenuse is always opposite the right angle. How do you know which is the right angle? Well, it's not the wrong angles, Mr. Myers, so it's got to be the right angle. How do you know which is the right angle? How do you know which one has the 90 degrees? No. It's got the symbol. The only thing that makes it 90 is that. The reason I make that point is if I draw something like this, where's the right angle? Right there. Does it look like a right angle? No. What makes that 90 degrees? That square, no matter what. Do you understand me? If that square is not there, can you do Pythagoras on that triangle? No. What if it looks like it's 90? Can I do Pythagoras on that triangle? No, unless this exists. Or you do the Pythagorean theorem and you prove that to be 90. Understand? We'll come back to that in a minute. The legs are the other guys. Two sides. And this is the next mistake kids make. They are interchangeable. One can be A, one can be B. It doesn't matter. Which is why I don't like to use A squared, B squared, C squared. I like to do leg 1 squared plus leg 2 squared equals hypotenuse squared. or L1 squared plus L2 squared equals H squared, because the letters don't matter. And when you memorize a squared, b squared, and c squared, I can mess you up. Because all I have to do, don't write down what I'm about to do, but all I need to do is give you this triangle and say A 12 and 13. And you guys will do that question wrong. You won't, because you've been through this lecture. But a bunch of kids in this room would do that question wrong, because they would be thinking a squared, b squared, c squared. Okay? And it would piss me off, because there's no need for it. Because all you had to do to fix it is not teach a squared, b squared, c squared, but teach legs and hypotenuse. Okay? Everybody cool? Remember, just like in all the other formulas from the first unit, the letters are just there so they have a name, right? I'm the math teacher, but my name is Mr. Myers. You're the students, but you all have names. I don't say kid, right? You get a name. But there are other kids that sit in your desk. They all have their own name. Everybody good? All right. I am aware that it is a blizzard outside, but it isn't really, because a blizzard also has sustained high winds. And as you can see, there are no winds. All right. Please, 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 please. All of you should already be able to tell me the unknown on here. Get out your calculators. Do whatever it is you need to do to tell me what those two numbers are. Then I want to talk to you about what you did with your calculator to get those numbers, because there's a way to make it more streamlined, okay? So first of all, find the numbers, write them down. Don't yell them out loud. Just find them and write them down. Okay, I'm going to write down the right answer because I want everybody to yell it out. This is 17, and this is 8.9. All right? Everyone's able to get that, yes? My guess is that you got this on your calculator by doing 8, the x squared button, plus 15, the x squared button, then equals, and then you did square root of this answer. My guess is that's what you did. And that's fine if you can do that. That works wonderfully. However, you can get it more streamlined by using the brackets. The only reason I'm telling you this is because in previous grades, the whole point of this question was to find the one missing side, right? And you practiced it a ton. But now, that is not the point. That is the first step. So you're going to go much further than that. So it is good if you are aware of how you can enter this into your calculator in such a way that you can go further with it. Okay? You don't have to learn what I'm about to tell you, but it may help you, so I'm going to show it to you. Remember, there are two kinds of calculators. Either you push square root 81, square root 81 equals to get 9, or you push 81 square root to get 9. Those are the two options, yes? Everybody understands, obviously, because that's what you have. You all have one of those two calculators. Who has the one that you punch it in the order you read it? Who has that? Only 2, 3, 4. And who has one of these backwards ones where you got to push 81 square root? Okay, that's going to be a real pain for this unit, but it's okay. It still works. Don't worry about it. So if you have the first one, this one, if you want to do this question all at once, here's what you would do. Square root, and all of you should practice this because it will help. Square root button, bracket, 8x squared plus 15x squared, that button with x squared on it, close brackets equals, and you will get the answer of 17 all in one shot. Does everybody see that? If you are working with the other kind of calculator, you just reverse the order. You go 8x squared button plus 15x squared button, put all that in brackets, then hit square root, and you may or may not need to hit equals, and you will get 17 all in one shot. I recommend starting to practice this a little bit, because as you go further in math, the calculations become more and more advanced, and you guys refuse to write stuff down. And when you refuse to write stuff down, you lose track through your work. Everybody cool? Now this one over here was a subtraction one, yes? So if you wanted to do it all in one go and you had a forward calculator, it was square root bracket 12x squared minus 8x squared, close brackets equals. And if it was the other calculator, it was bracket 12x squared minus 8x squared, close bracket, square root, and may or may not have needed equals. Is everybody good with finding the hypotenuse and legs? If you have trouble remembering which is which, just remember this. If you need the hypotenuse, you're adding. If you have the hypotenuse, you're subtracting. Okay? Everybody cool? All right. So let's look at this next question. And this is what I mean by stuff gets more difficult as we go along. Look at example 2 and tell me, don't actually do it because you probably need to talk to your neighbor. If you can, tell me what x is. Talk about it first and then try it. And if you can, see if you can figure it out. Or do I need more information to solve that? Emily says I need more information. Why, Emily? I'm not saying if you're right or wrong, just why do you feel I need more information?
You don't know if whatever thought was at the 20 centimeters is equal and that at the end of the side.
So Emily's first guess was that this was 20 centimeters. Right. We don't know that. Okay. What is another assumption that you could have made? Emily again.
That x is half of 35.
You could have said this was half of 35. Can you do that? Are you allowed? No. Is there another assumption you could make with this? L. Yeah. If you drew that, you're saying? Okay, that's not an assumption. You're allowed to draw that. That's where we're going with this. The other thing I wanted from you guys is a lot of kids say, well, that's 90. Are you allowed to do that? Why? Because it doesn't say it's 90. All right? So now the question becomes, how do we do this? Well, what do you need to find the sides of a triangle? You need at least 2, don't you? Where do you have 2 sides of a triangle? You don't, do you? Only this big one, right? So L suggests we cut this right here, yeah? What does that do for us, Al? It makes a 90 right here, yeah? Everyone agree? Okay. How long is that? That's 10. Now, can you do some work with this question? What could you do? You could find which hypotenuse? Would it be? Does that line have to cut this triangle in half? Does it? You think about it for a moment. Can everyone see that? If I cut that in half, or if I draw that vertical line, that gets me this, doesn't it? Does everyone agree? Is that half? So can you make that assumption? No, you cannot. But what can you find now that we have done this? I will do some highlighting to help. You can find right here, can't you? Oh, I don't want to say x because we've already used x. I'm going to make this y. Can we find y? Okay, how would you find y? Pythagoras. So it's not a hypotenuse, so are we adding or subtracting? Subtracting. So y equals the square root of what? 20 squared minus 10 squared, which is the square root of 400 minus 100, which is the square root of 300. And we go to our calculator and find out what that is. And we find out it is about 17 and a half. Right? I don't know exactly what it is. Square root 300 is 17.3. Right? Is that half of 35? No, it's not quite half 35, is it? So this part is 17.3. So what does that tell us about this part? 17.7, isn't it? Right? Does that give me x? Don't they have to be the same? Does that give me x? Okay. Could we also find it by using this to find this hypotenuse? And then using Pythagoras to find it? Is everybody with me? Do you all see the new layer that has been added to Pythagoras? In grade 5, all you had was one triangle. Now you've got to apply that along the way. Everybody cool? All right. Now, the second one there, good gravy. The second one I have there is doable. Why? Yeah, it's the same for me, man.
Yeah, we can find the angled side.
So we find this how?
Yeah, and then we can.
We're going to call him, we'll call that guy y. How would we find him? Square root of 10 squared plus 20 squared, yeah? So that's the square root of 500 this time, right? So I know what that is. Am I allowed to use the square root of 500 and the square root of 25 to Pythagoras for that? Why not? Because there's no right angle. So I got to do what? I got to split it again, make this what? What is this down here? 10. We already know y there, so then I can find that. So what I'm going to call this guy m. What will get me m now? I already know what y is, square root of 500, right? So m squared equals, or m equals what? It's going to equal the square root of something. Y squared, which is the root of 500 squared, right? What is the root of 500 times the root of 500? What is the root of 4 times the root of 4? 4. So what is the root of 500 times the root of 500? 500. So this is the square root of 500 minus what? 10 squared, which is 100, right? So m is the root of 400, which equals 20. So m is now 20. Now what can I do? I got to do Pythagoras again. I'm going to call this guy P. What will find me P? 25 squared minus 20 squared, which is 625 minus 400, which is the square root of 225, which is 15. So this is 15, yes? Have I found x yet? What's x? X equals 15 plus 10 to get 25. Now, is everybody cool? You haven't had practice doing it, so I don't expect you to be able to do it now. What I expect you to take from this is you need sometimes to find stuff that is nowhere near your final answer. Do you understand what I am saying? You must follow clues like Scooby-Doo to get to the end. All right? You're not allowed to make assumptions. You're not allowed to guess. This is math class. This is not English. English is full of guesses and assumptions, and that's okay. That's what makes fiction good. Everybody good? All right. I'm going to give you some work on that in a minute, okay? Actually, I lie. I'm going to give you work on that now. Okay, couple of rule changes. In your previous grades of math class, this triangle, you would have named it how? You wouldn't name it Bob. What would you name this triangle? It would be triangle ABC, correct? That's one way you could name it. How else could you name it? BCA, CBA, BAC, it wouldn't matter. You go corner to corner to corner, yes? If I name this guy ABC, I go A down the long side, up the short side, yes? So if this guy is ABC, what is this guy's name? FED. FED. Because order matters. Everybody cool? This guy is not DEF. All right? There's a reason I put the letters like that. So everybody says, it's DEF. It's not. Everybody cool? All right. So that's how you would name this guy. Now, in grade 9, if I asked you to give the yellow side a name, what would you name that side? Thinking back to grade 7, grade 8 geometry, what would you call that? You would call it BC or CB, wouldn't you? You would name this guy CB or BC, correct? And what would you name this green guy? He would be AB or BA, yes? And the blue guy would be AC or CA. Agreed? Ooh, I don't want to write that out there. I want to write it. Yeah, I do want to write it out there. AC or CA. Cool? Everybody understand? Okay. In grade 10, we don't do that anymore. And actually, we don't do that ever anymore. And I don't know why they teach it that way in elementary school, because that's not the way they do it. What they do now, and what you are going to do from now on, is you name the side by the opposite angle. What does opposite mean in trigonometry and geometry? Across. So this side is across from that angle. So this is little a. Because we name the sides with small letters. Okay? So in the 10th grade, sides are named with, it's not French, with the lowercase letter of the opposite, and I'm writing opposite in big capital letters, of the opposite angle. So that makes this guy A. What does that make this guy? Little c. What does that make this guy? Little b. Is everybody cool with that? Everyone is good? Yes? Okay. So now, name this triangle. What is this guy? Little f. What is this guy? Little d. What is this guy? Little e. Is everybody cool? Now, I take my worksheets and stuff from everywhere because I believe that the more ways you guys to see things written out, the better off you will be. So on some of the work I give you, it might still call this side DF. All right? But officially, this is how we label triangles. Corners are capitals. Sides are the small that's across the way. Everybody cool? All right. Now, the next thing is something, again, that you should have done in grade 9. I can't guarantee if you did, except for the few people that were in my grade 9 class. On the next page, I have some charts. I'm going to give you some of this information. We are going to find some of the rest of the information. Angle A is right here, yes? What angle corresponds with that on the bigger triangle? Angle F. And I'm going to tell you right now that angle F and angle A are equal. So on your next page, you have angle A is equal to angle F. Right? And angle F is equal to angle A. Fill in the rest of that chart. Doing it properly. B equals what? And C equals what? Who does B equal? B equals E and C equals D, yes? So B equals E, E equals B, C equals D, D equals C. Is everybody cool with that? All right. Now, this part of the chart, if you have three triangles that are the same angles, you have what we call similar triangles. And that means that they follow a certain rule. And the rule is this. Actually, I don't want to do it that way. Don't draw that. I'm sorry. I'm an idiot. I'm the worst kind of idiot. I'm so sorry. Sorry. The rule is corresponding sides are proportionate. What does that mean? That means if I compare two sides that correspond. So going back to our list, to our sheet that we had, what side does B correspond with down here? E, right? So what proportionate means is that B, if I compare it to E, and I compare all my other sides the same way. So what does F compare to? A. And what does C compare to? D. If I follow the same rule, A to F and C to D, what do I know about all of those fractions? That they are equal. Okay? Always. And normally we would measure our triangles and prove this. But nobody ever brings rulers anymore. Okay? If you have a ruler, go ahead and measure side A. And tell me what you get. Who would like to volunteer a number? Side A? Side A is right here, yes?
2 7/8.
Oh, you went inches, clown. 4.6 centimeters. What do you get for C? I get 9 centimeters. And what do I get for B? Yeah, I'll take 7.5. I get 7.4. Everybody cool with that? If you didn't measure it, you're believing us, yes? Okay. Now, everybody measure one side in the big triangle. Not everybody, but if you have a ruler, somebody measure one side. Doesn't matter which one. Whoever says a number in a letter is who I'm going to go with. Side E, you say, is 11.5. Okay. So L has told us this is 11.5, right? Now let's do some work with that. What side does that 7.4 match up with? 11.5, correct? So if I go to what I know now, that is B and E, isn't it? Right? So B and E right here is 7.5, or was it 7.4? 7.4 over 11.5, right? What does that tell us? 7.4 over 11.5. Do I know side A? It was 4.6, yeah? Did I ever measure side F? Did I? So what do I put there if I don't know the number? I put a variable. What variable should we use? F, because it's side F. Did I ever measure side C? What was it? 9. What was side D? Did I ever measure it? No, it's a fraction. Right? And it's a variable. But what do I know about all three of these fractions? They have to be equal, yes? So 4.6 over F and 9 over d. How do we solve those? Same way we were solving stuff last unit, right? Multiply diagonally and divide the spare. Where's the diagonal pair here? So what would I punch into my calculator? No. 11.5 times 4.6 divided by 7.4. Everybody should do that and tell me what F is. Pardon? 7.1. Now, do I have a pair in this group? I do now. What is it? Where's my pair and spare here? 9 times what? 7.1 divided by what? 4.6 will get me D, which is what? 13.9, yes? Everyone agrees? Let's check with our rulers. F, look at that, 7.1. D, look at that, 13.9. Everybody cool? Now, what does that tell us about the effect that these lengths have on these angles? Is there one? Does the length of the side affect the angle? It's a yes or no question, guys.
Yes.
The length of the side affects the angle. So I have two different triangles here with different side lengths.
Oh, yeah.
Doesn't affect the angle, does it? Everybody understand? If the angles are the same, then we can apply that knowledge to bigger and bigger triangles. How big do you think that rule will allow us to go? I'll give you a hint. It's math class. How far do math rules go? Always. Infinite. Everybody good? So that tells us that no matter what we do to the sides of a triangle, the angles do not change. And we have now seen there is a relationship between those sides, isn't there? And if those sides have a relationship, then don't those sides also have a relationship to the angles? Again, yes or no? They must. You don't know what it is yet unless you've done trig. Everybody cool? All right. So what I want from you guys today, and I'm going to shut up right now because I can give you the rest of the day to work on it, is the next Pythagoras page using the Pythagorean theorem. Okay? Real life problems that you need to use Pythagoras for. Again, not really real life problems, but you know what I'm saying. So the rest of your guys' homework, and I'm going to write it right here, is using the Pythagorean theorem. And I wish I could write the page numbers, but I still can't yet. But pretty soon we're caught up to where the page numbers are printed. 2 more pages. Yeah. Aight? Aight.